stabilized, at which point whatever constants you have discovered are the constants in the program. Okay. So this is more complex than simple constant propagation, because you not only need to keep track of definition and usage, you also need to keep track of executable edges. So you need two work list, flow work list and SSA work list. So flow work list is a work list of all flow graph edges. So what I am marking as F, F1, F2, F3. SSA work list is similar to the previous work list of SSA graph edges, what I have marked as E1, E2, E3, E4. And now because you are maintaining two to-do lists, so your work is over when both those lists are empty. It can happen one is empty but other is not. Okay, so maybe you are keeping your home work list separate from your school work list, college work list. So, but then your day is over only when both the work lists are empty. And how do you maintain whether a path is executable or not? So you associate a flag called executable flag with every flow graph edge, with every F here. I hope I am not repeating F anywhere else. Yeah, so F is not a variable. Every F edge here will have a flag which will say whether it is executable or not, and this edge or this flag will control whether we consider corresponding VI or not, value or not. Up to this, everything clear? Any doubts? Don't say later that things are not clear. Idea is clear or still some doubt? Please go ahead, please ask, there is no problem. This is a very complex algorithm. I should not say that, the next one is more complex, this is much easier. Intuitively, is it clear? Something I want, some cue whether it is clear or not. Yes. So which line has you have doubt? I mean, this is not how it should happen, right? At least either you say yes, I understood everything, or you say something is not clear. Which step is not clear? Okay, I think then everything is clear. Let's move ahead. So if a program is there, what can you say about what will execute to start the program? Okay, you cannot start with both the work lists being empty, because if both of them are empty, then you are anyway done. So something you know about the program. What do you know about the program? That the first statement of the program has to execute. Right? If you execute the program, do you know what executes? Where does C program execution starts? If I use C program, where does it start? Main function from user perspective, yes. Okay. So in some sense, first statement of main has to execute. Right? So if I give you a program, anything else may or may not execute, but the first statement of main has to execute. Similarly, if I tell you that I am going to execute this function, the first statement of that function has to execute. So entry has to execute. Okay. And generally entry node, you insert yourself. If you remember, probably Professor Khedkar must have told you, entry is a concept which is coming out of entry. You execute that line, which is a blank line, but then you move on to the next node, right? So anything which is coming out of entry is executable. So that is why you have to initialize work list, flow graph work list with entry node, edges coming out of entry node. So we'll only insert edges coming out of entry node. So here I have FWL, flow work list and SSA work list. So this will have F1, flow work list will have F1 to start with. Is this point clear? Any doubts why we should add F1 to FWL? Is this visible to everyone? Okay, if it is not visible, it will be difficult, so then you'll have to move around, find some place. This is not the ideal situation, but we have to work with that. Okay, what about SWL? So SSA work list. So initially we don't know, entry node is empty by definition, the way we have inserted it, so nothing. So SSA work list is empty, flow work list is initialized with the first edge in some sense. Also every edge, see again we start with an optimistic assumption saying that nothing is going to execute. So we get everything as we get a program which is totally optimized. Nothing is working, okay. Please ask everyone, I am asking, nobody is responding. So I am assuming that it is visible. See, these are the things you have to tell because for me it is visible, I am close to it. If it is not, please tell us. It's a classroom and you should get best possible access to information. Okay, so why is every executable flag false initially? Yes? No, executable flag tells whether edge is going to be executed or not. Whether I should consider value coming across that edge or not. No, I'm talking about every single executable flag with F8, F7, F6, F3, F2. All executable flags are false. Yes. Yes. See, always data flow analysis, intuitively, you start with best case scenario and then whenever you discover real information, it will be always less than best case scenario because you are assuming everything is constant, which is the best case scenario, but then you will discover something not to be a constant. Okay, so you come down. Okay, so I use come down because there is a lattice, visually it is top value bottom, so it always go down the lattice. And other thing is, even if in reality there might be some other issues, for data flow analysis kind of situations, or most of the time when you are doing iterative analysis or work list based analysis, you only want to move in one direction. As we saw yesterday, we do not want to keep going from true to false, false to true, true to false, false to true like that, because that will make it difficult for your algorithm to terminate. It might go into an infinite loop. It will always discover 2, 3, 2, 3, 2, 3, 2, 3. Okay, it will not know when to stop. If we are forcing it, either goes from 2 to 3 and then never goes from 3 to 2, or reverse is also fine, doesn't matter. As long as things are moving in one direction and as long as there are finite number of things, you will end up at a place where you will keep repeating the value. So 2, 3, 3, 3, 3, 3. So you know, once 3 is repeated, you know that you can no longer change, so you stop processing. Okay. Similarly here, we start with an executable edge to be, all executable edges to be false, and some of them will be marked true as we go along. Okay, and then we will process those edges only, or those values only. Every value initially is top. Okay, again we are saying everything is a constant. Some constant I don't know, as I said, dummy constant. I don't know exact value, it's a dummy constant. So how do we work? Again, we work exactly like we do in any work list. We have to pick up a value, we pick up an item from work list, process it, insert newly discovered tasks in the work list. So in this case, as I said, you have two to-do lists. One is your school to-do list, one is your home to-do list, homework and classwork. Okay. At the end of the year, you have to finish both of them. So it does not really matter which one you perform first. Assume these tasks are kind of independent. Okay. So there are some household chores, there are some school work. You can do household work first, Maybe you are someone who wants to study at night, so you first do all household work and sit at night to finish your school work. Some people want to sleep early, they want to do school work first and delay household work, okay, like that. So you can do any of them. In fact, you can mix and match, sometimes pick this, sometimes pick that, doesn't matter. As long as you are going to finish every single task in both work lists. Then you have to process the item. Again, this will depend on item itself, so it is described later, but this is the high level thing for any work list based algorithm. So how do we process flow graph item or flow edges? If I decide to pick up an item from FWL, okay, how do I process it? If I pick up an item from SSA work list, how do I process it? So for example, if I do this algorithm, right now I only have one choice. I only can handle flow graph edge. What do you think I should do? I can be anywhere for that matter. Okay. So if I pick up a flow graph edge, what should I do? What will flow graph edge be like? It will connect some basic block 1 with another basic block 2. This will be my edge Fi. What do you think I can do with that? Intuition. You have to discover properties. Whether a particular variable in B1 is changing, why do you need that information? Why did Fi go into the work list? Why did you insert Fi into the work list? I mean, intuition. As we see, we keep adding. Why did you see Fi? No, I'm saying in general. See, initially starting point is okay, but I will sometime add F4 maybe or F7. Why will I add F7 to my work list if I add it? No, then why will I check F7? Why not F3? Why not F2? At any point I decided to add F7 to the work list. What do you think I was doing at that point? So when I decided to F7 to the work list, what thing I was processing? So that's why, tell me. No, don't think too complex. Think simple. I have an edge which goes from B1 to B2. I am trying to execute the program mentally or for analysis purpose. I decided that this edge is interesting. What do you think I was processing just before I figure out this edge is interesting? When I add F1 will by Fi, was I executing B2 or was I executing B1? See, when I process B1, at that point I will realize, oh, this is an interesting block. I should look at what is coming next. Is it true or not? See, when I add Fi, just before that I must be processing B1, not B2. If B2 is there, B2 is done. Why do I go back? It's a forward propagation. Remember, constant propagation is a forward property. If it was a reverse property, backward property, then B2. So if I look at an edge, I have to see the source of information. So when I process this node, then depending on what happens here, I have to execute next statement in actual program. So in my analysis also I have to mimic that. So only when I process this edge, I will be, or this node, I will add F6 to the work list. When I process this node, if I figure out A less than B is true, I add F4. If I figure out A less than B is false, I add this node. If I cannot figure out what is A less than B, what should I do? I am not sure, is it true, is it false? So then I will add both. Because at runtime, this edge can execute, that edge can execute. So is this intuition clear? So why do I add an edge to flow work list? Because the source node, okay, or head of a, I don't know whether you call it head or tail. Basically, the from node of that edge has been processed, something interesting has been discovered, which tells you that this edge is going to be executed in the program. Okay. So if our item is flow graph edge, what will you do? Now that part is done. I have added it some time back. Now I come to this edge and pick it out. Now I have taken out F4 from work list. What should I do now? In some sense, I know that F4 is going to be executed in the program. So what will I process now? B2, or the target of that edge. Is it clear? See, earlier I has processed the source, which made me add this edge to the work list. In other words, I discovered new work to be done at the target. So later when I pick up this from the work list, I will process the target. This target will create new edges in the work list or add new edges to the work list. Again, next time I will process those targets, and I keep doing that till I kind of reach the end of the program. Okay. Now this is interesting thing. If executable flag is true for that node, this was intuition, so that's why we have to be little careful. Suppose I picked up F4 and executable flag is true for that. We are doing nothing. Keep this in mind. You ask this question, why are we not doing anything? Even though I said I have to process the target and all. Any guesses? Otherwise we will come back to it. No, first is, if it is true, we are doing nothing. Okay, so let's not discuss this right now because we have not seen complete picture. The flag is false. Okay, so first thing we do is mark that executable flag as true. The reason is, again, we process B1, accordingly we discovered that this edge is going to be executed, so we added it to the work list. So when we are processing Fi, now I know that, okay, this edge is going to be executed at runtime, so I mark its executable flag as true. Okay, so not only this executable flag is telling me this edge is being executed, or in some run it will be executing, it is also helping me kind of track its visited status. Has it been visited earlier or not? So if visited executable flag is true, that means I have already processed that edge some time back. Because remember, we can also add same edge multiple times. There might be multiple blocks which will cause B1 to be processed. If B2 node, the destination node, contains phi function, I have to process them. We'll see how to process it. So the function I am calling visit phi. Visit phi will do something what we described earlier. Choose those values which are reachable or executable and only take meat of them. If only one of the executable flags of incoming flow graph edges for the destination is true, then we have to visit all the expressions. So again, look at this node, this one. Okay, there are multiple incoming edges for C3. Okay, sometime this will be processed, sometime this will be processed, it could be first or later, but you will visit C3 in some way multiple times. The body of C3 you need not evaluate again and again, only first time when you see an executable flag being true, you visit that. Okay, so you will visit all the expressions or process all the expressions. Again, this I will show in the next slide. We will do all the thing, we'll come back to this. We'll have to pass over the algorithms because there are a lot of forward references right now. Yes.
If we pass only one time, then we won't be able to see the other branch of the same.
So that's your query, we'll see. Okay, that's why I said we'll come back. Keep noting these challenges. Why executable flag is true, then we don't do anything. Why we are visiting only when one single executable flag is true. Okay, so we'll come back. That's why I said all these are optimizations. And if the destination contains only one outgoing flow graph edge, add that edge to FWL. So if B2 has only one outgoing edge, that means it's like a unconditional fall through. Okay, so you add that edge. So earlier B1 caused Fi to be added, now B2 will cause sub Fj to be added. I'm not drawing it as a dashed edge because that is SSA edge. Okay, so when we process B2, outgoing edges of B2 will be added depending on certain conditions. So this was when I had picked up F1. Okay. We still have not shown when SSA edge will get added. That we will see in visit phi and visit expression later. Okay, but assume some SSA edge has been added and it is there in work list. What will you do? This is very similar to what we did earlier in sparse constant propagation. Okay, your item is an SSA edge. If the destination is a phi function, you have to do a visit phi. Otherwise, similar thing, if destination is an expression and any of the executable flow flags is true, you have to do visit expression. So once again, you are targeting SSA edge. Okay, but destination, this node will execute if at least one of these executable flag is true. If all of them are false, then this destination is not even going to be executed. This is important. Okay. In case of flow work list, we did not have to check that because we are coming through flow work list, which means we are actually executing one of the edge. Here, SSA edge might say, oh, from here you have to jump here, but flow graph edges are saying, oh, this edge, none of these edges are going to be executed, which means this block is not going to be executed. That is why you have to check for at least one executable flag to be true. Okay, clear or not this part? So again, we'll do two pass on this algorithm. What is visit phi? Visit phi is exactly what we discussed, the key idea. If V1, V2, Vk are our k branches which are merging, if ith branch has executable flag true, you pick up Vi. If it has executable flag false, then you pick up tau, or you actually drop it in some sense. Okay, putting top means you are not ignoring that. Okay, so this way you are only choosing those paths which you have discovered to be executable. Is this point clear? If a path is not executable, on this path we are assuming value is top, which is the optimistic value, which in a sense says that I don't care, whatever constant you want you can pick up. So I am going to help you. Okay. So or you are in some sense saying ignore me, I am not going to change anything for you. So this is the way of mathematically doing that. Ignoring edges which are not executable yet. Later it might discover to be executable, so you will see that it will again get added to work list and you will process this V again. Yes or no? Anything? Any questions yet? So very simple. What do you do for visit expression? For every expression? So this is just a meet over all the values which are non-tau. So visit expression, again this is something we did when we looked at SSA based sparse simple constant propagation. You evaluate the expression. So evaluation requires some rules because some values will be top, some values will be bottom, some values will be constant. Okay, you have to handle all that using rules of your programming language. Okay, rules for operators and values for operands. So remember, value can be top, value can be bottom, which is not a constant, or value could be actual constant. So I can have x plus y, and then we have rule about how to treat them, all three kind of values. If the result means you have to also store the result corresponding to previous result. If there is no change, then nothing has changed, you don't have anything to do. However, the result can change because values are continuously changing. If this expression is part of an assignment, then remember, if there is an assignment, we will have an SSA edge in that block. because that's what SSA is. So you add all outgoing SSA edges to SWL. I mean corresponding to this assignment. I should not say not all over in the program, in this block. If the expression controls a conditional branch, so if it was this, you will add outgoing edge. Okay, there might be multiple assignments, so you will add all whatever is changing corresponding SSA edges. If it is controlling a conditional branch, then what will you do? Yes. So I know I evaluated A less than B. I got a value. This value has changed. What will I do? If you are executing the program, what do you do? Okay. Executable flag of what? So there are two branches originating from this. And you have evaluated A less than B. Now what are the different possible values for A less than B? And not a constant also, because you don't know what A is, what B is. It might be A is not a constant, B is not a constant. Okay, so all three values are possible. You know what the value is true, you know what the value is false, when the value is false, or you cannot know the value. So undecided. What if the value is true? So you will set executable flag for left branch to be true. If the value is false, right branch. If the value is undecided, if the value is top, you don't do anything. Okay, in fact it won't happen. If the result is bot, basically not a constant, add all outgoing flow edges to FWL. In fact, okay, so let me take a step back. We never do executable flag true at this point, because when we pick up the element, we do executable flag true. Remember in previous processing. Okay, at this point you only add it to work list. Okay, because as I said, we are using that executable flag also to decide if the edge has been visited already or not. If you do it now, later you will not even visit it. Okay, so you are just adding. Is it clear why we add all edges to FWL? Because all of them are possibly going to be executed. If the result is a constant, like true or false, only the corresponding edge will get added. Okay, I am just keeping it C, because if you have switch case kind of statement, C1, C2, C3, C4, then you can have multiple branches and only a specific branch will get added. If it is Boolean, that true or false, you could add corresponding branch. Okay. Is it clear or not? What if it is top? Can the value be top at this stage? Why? Why it cannot be top? At this point, look at the algorithm, and at this point value cannot be top. In your program, if you are writing a program, if you get a top here, that means something wrong has happened. Again, this is nothing to do with data flow analysis, this has nothing to do with the complexness, this is only about this algorithm, the program. Look at these two lines. What does this say? If the result is same as previous, don't do anything, which means result has changed. Result has changed, but remember, we are never going from anything to top. We only move from top to mid to bot. Okay, so if result has changed, either you have gone from top to mid, or top to bot, or mid to bot. You can never go from something to top. So here value cannot be top. And this has nothing to do with this is only because of this if then else. Okay. Okay, so this is all. Should we go back? So when we process, so when do we add flow work list edge? We have processed an expression and we figured out few things about the expression. So let's see, when do we add flow work list edge? In visit 5 we don't add it. Okay. Only when we are visiting an expression we add it. And where do we add it? Whenever there is a control. Okay. Somewhere there should also be, I think there should be two places. Yes. So one is this, when it is a non-conditional. So you are processing a block and it does not have a condition at the end. So next block has to be executed. So we add that destination. Okay. I have processed B1. I know I have to process B2 sometimes. So I will add FI. Second case is when I have processed a conditional block. In which case, depending on what I evaluated, I will add one or all edges to the flow work list edge. Okay. So later when I process this flow work list edge, first thing, if executable flag is true. Now notice that I am not really interested in all kind of things. I am only interested in whether current block is going to be executed. If it is executed, which block it is going to matter. Okay. If the flag is already true, that means I have picked up this edge earlier also from work list. At that point I must have done all these things. Okay. So then I don't have to do anything. But if it is not true, then I will set it as true and do certain things. Okay. What are those certain things? One is visit phi. Visit phi processes your phi expression to calculate its value. If the value changes from the previous, then you process the rest of the things. Other is this thing, visit expression, which will do non-phi expressions, which will evaluate non-phi expressions. Again, depending on the value, it will put all the outgoing edges into a work list. Okay. So this is complexity. But before that, let's go to practice example. Same example. And we will do it in very much detail. I think maybe till tea time or even after that. Because now I don't want any confusion regarding how you process work list. So all executable flags are 0. Or false. Okay. So this is my work list, this is my executable flag. So intuition is clear. So what will I do? Now I have to start executing sparse conditional constant propagation algorithm. First step is add outgoing edge of entry to work list. That I have done. What is the next step or the generic step? I have to pick an item from either of the work list. Okay. Which item I can pick? F1. So I picked, this is the picked item. So F1. What do I do? This is a normal flow graph edge. Now first thing we have to check executable flag. Executable flag for F1 is false, which means we come to last part otherwise. Okay, do step by step. Mark the executable flag as true. So I marked it as true. Okay, You all understand 1 means true, right? I don't have to go back to binary. Okay. Now we do visit phi for all functions in the destination. Destination contains only one statement. Okay. And another thing, I forgot, all variables are also mapped to top initially. So A, B, C1, C2. This is also initialization part. I missed that. They are all top. Okay. So now visit phi I don't have to do. If only one of the executable flag is true, which is also correct. Now only one incoming flag is true. Okay. So destination is visited for the first time. Again, this holds. We have never seen this block yet. So this is visited for the first time. Now I have to do visit expression for all expression. So I have to do visit expression for A equal to 2. Let's do that. Okay. So what I have to do? I have to evaluate expression on the right hand side. Okay. So I do that. If the expression is part of an assignment, add all outgoing edges to SWL. So basically result has changed. Okay, sorry. So I evaluate expression. The value comes out to be 2. The result has changed. Result has changed. So I have to go down. Expression is part of an assignment. It's A equal to 2. So assignment value has changed. I have to add all outgoing SSA edges to SWL. Okay. Please follow this. Is it now clear? Getting clear or no? Okay. Not yet, not yet. Go step by step. Let's go step by step. We are reading each line here. If the expression is part of the assignment, add all outgoing edges to SWL. We did that. If the expression controls a conditional branch, does it control a conditional branch here? No. So that is skipped. So we are done with visit expression. We have to go back to our, this is a visit expression function call. So this part is done. Now we come to last part. What does it say? If the destination contains only one outgoing edge, then add that to flow WL. So does destination contains only one outgoing edge? Destination is this guy right now, F2. So what do I add to FWL? F2. At this point my processing is over. F1 is processed completely. Okay. What will I do next? Pick another item from any of the work list. Which one should I pick? Even? Someone said F2, someone said even. Now third person, you tell me which one should I pick? Even. Okay, I will pick up even. Lukman, I remember few names. So if you interact, then I will remember your name after some time. Okay, even is a SSA edge. SSA edge. So this is SSA edge. What do we do? If destination is a phi function, so E1, this one, is destination phi function? No. So we are skipping that. If destination is an expression, destination is an expression. Okay. And any of executable flags for the incoming edge of destination is true. What are incoming edges? Incoming flow graph edges. F3. Flag of F3. So we have to skip that. Okay. We don't have to do anything. Again, why are we not doing anything? Because as of now, I am assuming that this edge is not going to be executed, which means this block is not going to be executed. So why even process if something is not going to be executed? Nobody has given me any hint that this block is going to be executed. So I am optimistically assuming it is a dead code. So I stop here. So E1 has been processed. Let me go back. Yeah, so I don't have to do visit expression, and E1 is also processed, completed. So gone. What do I do next? Now I have no choice. F2. Do you remember, or should I go back step by step? F2 is this. So now I have to start processing. B equal to 3. First I try visit phi, not applicable. I have to do visit expression. Should I skip or go again one by one? Let's do one by one once more. So item is a flow graph edge. Let's see, that's good to do one. Executable flag is true. No. Executable flag is not true, which means I have to go forward here in the otherwise block. So first thing I have to do is change it to 1. Okay. Now I have to do visit phi. There is no phi. Now I have to do visit expression. Visit expression also at least one executable flag has to be true, which is there. Exactly one. Okay, only one. Okay. So for visit phi, again I evaluate the expression because exactly one incoming edge has executable flag to be true. B equal to 3, I evaluate it, value of B becomes 3, which means there is a change in the value, result is no longer the same, which means I have to add all SSA edges to SWL. All SSA edge to SWL. If the expression controls a conditional branch, no. So I don't have to do anything else. I am done. So, I had picked up F2 and F2 is also now handled. We have to add, oh yeah, still one more step remaining. Yes, sorry. This visit expression is over. Now next is if desk contains only one outgoing edge. Desk contains only one outgoing edge, so this also has to be added. Now the processing is over. Okay. Am I going slow enough or fast? Let's pick up F3 now. Okay. So last time we picked up E first, F later. Now we'll pick F first, E later. So let's pick up F3. Yes. So first thing you check is if executable flag is true or not. It is not true, it is false. So we have to move into the otherwise part. Next thing, I change it to 1, true. Next step, I do visit phi. There is no phi. Next, I do visit expression. Okay. So visit expression, I evaluate the expression. A less than B. What is A? What is B? 2 less than 3 is false. False. 2 less than 3. So this evaluates to true. Okay, so result has changed. Earlier, again I did not say that, but expression like A less than B, top less than top, using the semantics, this will also be a top. This is also optimistic. Okay, I can, because top says you can do whatever you want, I will pick up a proper value of A which is smaller than proper value of B. Okay, so I can get a top value here also. So this also has changed, which means I come to otherwise part. Expression is part of assignment, yes or no? Look at expression. It is not. Why are you saying yes? It's A less than B, condition. Expression controls a condition branch. Is result bought or not a constant? Is result a constant? True. Okay. So only the corresponding flow graph edge is added to FWL. Only the corresponding flow graph edge is added to FWL. So which one we are doing? F3, right? Who? Yeah, true is a constant. Boolean value means it can be true, it can be false. Now we have figured out this is can only be true. A less than B, 2 less than 3. It is a true value, it's a fixed true value. If here it was undefined or NAC, let's say NAC, and this also NAC, not a constant, then we don't know whether A is 2, whether A is 3, whether B is 7. So then we can't say anything, then it will be bought. So A less than B we evaluated to true, which means only true branch gets added to flow work list. Okay. Now this has been completed. Let's go back. Visit expression is done. If the destination contains only one outgoing flow graph edge, that's not true. We have two outgoing edges. So you can see that if there is more than one, it will be taken care by visit expression. If there is only one, it will be taken care by here. So right now I don't have to do anything. So F3 is also done. So what do I pick up next? F4 E2, you tell me. Yes, I asked you. You. E2, okay, E2. What do I do? E2, where is E2? Here. Okay. E2 is an SSA item. Is destination phi? Destination of E2 is A less than B. It is an expression. It is an expression. Is any of the incoming edge has executable flag true? There is only one incoming edge. What is its executable flag? True. Okay. So we have to process it. Remember earlier we had ignored it when we came from E1. Now when we are coming from E2, we are going to process A less than B. So we have to perform visit expression. So evaluate the expression using value of operands 2 less than 3. Answer is true, but already we have kept that as true. So nothing changed. Since nothing has changed, we don't have to do anything. Okay. Even if you do something, it will be a useless work because you have already taken care of this previously sometime when you visited it. Okay. So we are done with this. Visit expression is done. That's all. So this also has been taken care of. So now only thing remaining as of now is F4. F4 is this person. So I will pick up F4, check whether its executable flag is true or not. It is false, so I have to process it. I process it. Then I check what is the expression here. There is no phi here. Now I am going little fast. So visit phi does not apply. Visit expression applies. So I evaluate it. C1 becomes 4. And there is a change in the value, which means SSA edge has to be added to the work list. Okay. Anything else? Let me see, I also forget. So it is not part of an assignment, so I am done. Yes, so now we come back to this person. So destination contains only one outgoing edge, F6. So F6 has to be added. Okay. So at this point F6 and E3 are in my work list. Now you tell me what to process. E3. Let's pick up E3. It's an SSA edge. Destination is this phi node. So it is a phi node, so you have to do visit phi. Okay, finally, actually there is only one phi node. So visit phi says you have to check executable flag of incoming nodes. This is 0, this is also 0. F6 is 0, where is F6 is 0, F7 is 0. Okay, so all the values here we will keep as top. So again note that even though C1 we have discovered to be 4, when computing phi we will use top value here, because once again we still haven't come across an edge which we know is going to execute to reach this node. This node is still unreachable because you cannot reach it through F6, you cannot reach it through F7. Both F6 and F7 are 0. Is this point clear? There are two things. Value is constant, we have discovered it, but we are still not using it because target node is unreachable as of now, at least on that path. On F6 it is unreachable, on F7 it is unreachable. So we really don't have to process the node. Okay. So what we are taking? We are taking both of these values as optimistic values top, and correspondingly C3 remains top. I have not used C3 here. Okay. So meet of all tops will be top. So visit phi is done. If destination is an expression and any of the expression executable flags, so anyway all the executable flags are false, so we don't have to do anything. Okay, so we are done with E3 also. So again next we are left with F6. So we pick up F6, check executable flag, it is false, we make it true. Then we try to do visit. Okay, so we are looking at destination. It has two incoming edges, one is true, one is false. Okay, so we all have to process the destination with visit phi, sorry, in this case, otherwise mark the executable flag as true, visit phi for all phi functions. Before executable we have to do visit phi. So visit phi. So remember we did visit phi because of SSA edge. Now we are doing visit phi because of flow edge. When we did it with SSA edge, all flow edges were unreachable. So we actually did not do anything. But now because we are coming through flow edge, we have to visit corresponding values. Okay. So when we do it through this edge, now C1 will get value 4 because corresponding executable edge is 1. So if I go to visit phi, if ith incoming executable flag is true, well I will be value of vi. Value of C1 is 4. So this time I pick it up to be 4. C2, what will I pick up? Ith flag of or executable flag of F7 is still 0. So C2 will be top. Okay. So 4 comma top. When you meet them, what you get? 4. So the value of C3 has changed. To 4. Okay. We are processing F6, so this one. Yes. So we have done visit Phi. If only one of the executable edges, then we have to do visit expression. Visit expression, note that this has an assignment, so we have to do visit expression. Okay, so I think we don't have to do much here, this already processed. Yeah, phi is taken care of, okay, sorry. But somewhere I think there should be, we have to add this edge, F8. Why is it not getting added? Okay, we are doing flow edge, right? Through F6. Okay, so that's why I was getting a mistake. Yeah. So visit expression is also done. There is no expression to visit. If the destination contains only one outgoing flower edge, then I have to add it. So F8 gets added. So only F8 is remaining. So, no, in my work list. Only F8 is remaining. So I process it now. Okay. F8 is really a blank box. I don't have anything. So even if you process it, nothing will happen. At this point, what happened? When I do F8, it does not have any outgoing edge, it does not have any assignment, so it's like nothing will happen. You actually should do all the steps still. Okay, so no new edge will get added to FWL, no new edge will get added to SWL. So at this point, my work is done. What I have discovered, A is a constant 2, B is a constant 3, C1 is a constant 4, C2 top, because we never executed C2. Okay, we don't even have to worry about C2. C3 turned out to be a constant top. Not just that, if you look at these flags, F8 will become, this will become 1 when we process it. Okay, you can clearly see that F5 and F7 can be deleted from the program without causing any problem. Both F5 and F7 are dead edges. They are dead code. Okay, so C3 is kind of dead, C2 is dead because it doesn't change its value, it remains undefined. F7 and F8 you can actually, if you want, you can delete it now. So what have we discovered? Earlier, if you remember, recall, we were only able to discover A is 2 and B is 3. C was not a constant, or C3 was not a constant. Now we are discovering an extra constant C3. Okay. Any doubts? Yes. It will take, so suppose, think about it. So challenge is because of this very simplistic. Suppose there are 100 blocks in between. Between this and this, there are 100 blocks, none of which use C1. What will happen if you do normal analysis like data flow? You will move C1 from here to here, then here to here. You have to process those 100 blocks. Currently, we don't have to.
But sir, at the end of the day, if the flow is before the 99, after the 99 block is executed, then only the next 100 block will be executed.
So, but you don't have to carry, see, in data flow analysis, every point has to have corresponding values. So your data structure grows so big. So, okay, let me ask you. If I am doing data flow analysis, I have to say A is constant to here, A is constant to here, A is constant to here, A is constant. I have to put point-wise information. With SSA edges, I only have to keep it at definition and use. In between point need not have it. Okay, that means I can directly jump from definition to use. The in between nodes, I don't have to process anything. I don't have to copy information, I don't have to do gen, kill, anything.
But still we have to execute the flow.
See, but that's the thing, when you are having things which are not dependent, most of this thing will be false. You will never even come here. So you look at this. So most of the time your results won't change, so you don't have to process anything. In all the blocks, it's a blank empty box with respect to C1. So result does not change. Okay. But if you are having data flow kind of thing, only going through flow edges, every block you have to evaluate all the assignments. because you don't know whether those assignments contain C1 or not. Okay, so that's what SSA edge is the give you advantage. Other thing is, this is another interesting thing. So now do you see why this is applicable? If only one of the executable flag is true, we process expression, otherwise we don't.
Because if all the executive flags are false, where the expression hasn't been,
If all executable flags are false, it is not reachable, so you don't do anything. When first time one edge becomes false, you are evaluating it. So you have multiple incoming edges. Whenever any one of them, exactly first one of them becomes true, you evaluate expression. But when second of them becomes true, like for example, suppose this was not true, this was not a constant, then you would have come from this path also. Through this path, you will not do visit expression when you are processing FWL item. Why? We will do visit of phi. Visit of phi is unconditional. Yes. So that's the answer. Yes, that's the correct answer. You don't have to worry about flow through this because phi will take care of it. See, if there are multiple edges, only way value can change is through phi's. Okay. For non-phi things, anyway, first time itself you have got the correct answer. For phi things, you don't need flow edges. You can directly do it through SSA edge. And that is the important thing. SSA edge can come from very far also. So in a way you are skipping all the intermediate blocks. So correctness is not an issue, efficiency is the thing. So you will be correct, but then if you don't use SSA edges, then why convert a program to SSA? So the biggest advantage of SSA is this fact that the information when it is generated, it goes directly to the destination most of the time. Okay, in very few cases you have to go through every single intermediate blocks. So def use chains are kind of free. Secondly, because variable is assigned only once, whatever property you get about that variable, it is not point specific. Every point where that variable is visible, the property holds. So I don't have to say A is constant at point X, point Y, here, because A can change only at one place. If it is constant at that place, which means wherever A is visible, it is going to be constant. So all usages of A, see only one definition. That definition you have said is constant. On the other hand, if it is not a SSA, you have to worry about this C, everything. Okay. So this renumbering kind of gives you that guarantee. So if I have to ask, is C a constant? Finally, C1, C2, C4 are internal versions. Is C a constant? I can't answer that because C is different here, C is different there. I have to say at this point C is constant, at this point C is constant, at this point C is not constant, like that. With SSA, I will tell C1 is constant, C2 is constant, C3 is not a constant, like that. Because each of them have an individual unique definition. That is the beauty of SSA. So when we store point information, program point information, this location information in data flow analysis, it is called flow sensitive information. Because with flow your information is changing. So normal constant propagation is flow sensitive. You have to say at location X, at location Y, at location block B1, at location block B3, what is the value. When you introduce SSA, it becomes flow insensitive because location information is kind of embedded in the version number itself. So version number tells you which location you are talking about and you don't have to explicitly maintain it. Okay, and two versions of same variable do not interfere. So you can see C1 is kind of will be used from here to here, C3 will be used from here to here. Actually C1, C2 interfere below. You don't know, but then you are kind of cutting that off saying, oh, I am introducing a new version. So this new version interferes below. C1, C2 lose their identity. Okay, this renaming helps in maintaining distinction between different locations where C is being used. So other thing is now you can try changing A to 3, B to 2, or changing A to not a constant some input and B to input, so that you get a not a constant. So you will see if both of them are not constant, you will also have to include this, and finally you will end up getting C3 as bot or not a constant. In that case, C1 will be 4, C2 will be 5, C3 will be not a constant. Okay. Any other question? Otherwise we can take a break now. 7 minutes early, but then we can come back and start. So let's have few questions. Yes. Okay. Yes, please. You have that mic. One is two of them are.
Hello? Hello? Okay.
Yes.
We so the blocks that we're using right now only have one statement in them. Like, can we use multi-statement blocks
We
so
can.
that we can reduce the amount of edges?
Yes, yes. So this is just for what you say for illustration purpose. I kept them separate. You can merge A equal to 2, B equal to 3, A less than B.
It would work like
It will work.
Okay.
Only visit expression has to process all the expression. Visit phi has to process all the phi's at the start. Okay, so you have to take care of that.
okay.
Yes. So what will happen? You will have a one single big block. Edge will go from that block to this one. Oh, this you have to keep separate, I think. In fact, you don't have to. Within the same block, you can do local information. It requires slightly more, some small changes. Okay, but conceptually it will be the same.
So at the end of each block, only like a block would terminate only when there is a
There's a branch kind of statement, or so there are few rules. Did you cover basic block construction? Leader statement. So you know then that a block is between two leaders. Yeah. Anything else? So that can also be an exercise, merging this block. Okay. So that will reduce number of SSA edges also. You don't have to worry about these edges. They are in the same. So local information you have to cover. All right. So we'll take a break now. We'll be back by yes. Okay.